So there's all the stuff, all the working, the commands and everything. So what about normal? Well, now instead of norm, we use norm dist. There is actually one called a norm sdist, which is for your standard normal. Remember, your standard normal is a special type of normal that has a mean of 0 and a standard deviation of 1. So you can either use these in norm dist or you can standardize and then use a standard normal. The other thing you have as well is, remember, sometimes what I will do is, instead of saying here's a value, what is the probability being less than or equal, which is the cumulative, and we're always going to be using the cumulative, because if I enter false in there, I'm going to get the height at that point, which I don't want. I want the area, the orange area. Sometimes instead of giving you x and asking what the orange area is, how big it is, sometimes I will give you the orange area and ask you what x is. And that is done by norm inverse, because we're doing the inverse process. Instead of getting x and giving you the orange area, I give you the orange area, you give me x. So we're going backwards or inverse. So here we are. We've now got cats, normally distributed, mean of 4, standard deviation of 0.5. So we're going to go let x this time be the rate of a randomly selected cat. And what do we know? We know that x is normally, just m for normal. We want to give the mean, because the normal also has 2 parameters, so we want the mean. The mean is 4. And we want the standard deviation. The standard deviation is 0.5. So the first question, we want a random selected cat is less than 3 kilograms. So we want the probability that x is less than 3. Now, just so you know, with the normal, not with the binomial, but with the normal, this is exactly the same as that. Oops, not that, that. That is less than, is the same as less than or equal. And that's just with the normal, not with the binomial. So, how are we going to do this one? So we go back. This time we get a new cell. We click on our function. We've got statistical. And we're going to go all the way down to norm. And there's norm dist. There's also norm sdist. Don't use that one, use that one. So you click on that one. So now we have to give the value that we're doing less than or equal to, which in our case is this number here, the 3. If you put 3 there, then you have to give the mean. The mean is 4, the standard deviation is 0.5. And with the normal distribution, you always put true there, always. There's your answer. We can put that in. We can copy it. So I've shown my working, and then we can give the actual answer. So let's highlight that. Let's move it to 4 decimal places. Let's now copy it and paste it. All done. Let's have a look at the next one. So we've got now weighs more than 4 kilograms. So what do we want? This time I want the probability that x is greater than 4. Well, because all we can ever get from Excel is less than or equal, we need to convert that less than equal. If you ever have greater than and you want to get less than, you just do 1 minus. So you go 1 minus the probability that x is less than or equal to 4, which equals, let's do that calculation then. U1 equal 1 minus, so we know we're going to put norm dot dist. The first number is the value we want, which is 4. Then we do the mean. Then we do the standard deviation. And then remember, we always put true. And there's the answer, 0.5. So let's write down our working. And then that equals 0.5. Next one. We want it to weigh more than 4 kilograms or less than 3 kilograms. So what do we want? We want the probability that x is greater than 4 or x is less than 3. Now, we've got an OR question. Can the weight of a cat be greater than 4 and less than 3 at the same time? No, it can't. So they're disjoint. So because these two events, x is greater than 4 and x less than 3 are disjoint, we can just add them. So that's going to be x is greater than 4 plus the probability that x is less than 3. Cool. Well, the nice thing is this bit we calculated up here, and this bit we calculated here. Remember I told you that less than or equal is the same as less than, so we can just basically go this is equal to 0.5 plus 0.1719, which equals so it's going to equal that one plus that one plus that one, so not point. That. Let's go back to the next question. This time we want between 3 and 4. Okay. Probability that 3 is less than or equal to x, which is less than or equal to 4, which equal, okay, so we want to convert this to less than or equals. First of all, you get the probability that x is less than or equal to 4, but unfortunately that has everything less than or equal to 4. So we want to take off the bits that are less than or equal to 3, because then what's left is between 3 and 4. So we go minus the probability that x is less than or equal to 3. See. So now we'll come here. So that's going to be equal the norm dot dist. First one we want is 4, 4, 0.5, true, minus norm dot dist. This time we've got 3, 4, 0.5, true. There you are. So we've got our working. And then we've got our, let's put this at 4 decimal places, our calculation. Lovely. And the final one, what weight C is such that 10% of all cats are less than this weight. So what we're saying that the area to the left, if you convert from percent to proportion, is 0.1. So basically we're saying that this orange area is 0.1 and we want x, so that's the norm inverse. So we're going to go equals, click on that. This time we want the norm inverse. So the probability is 0.1. So I convert to that 10% divided by 100, got 0.1. The mean is 4, standard deviation 0.5. Hit return, and that is, now because it's a number that's not a proportion or a probability, let's convert it to 2 decimal places. So here's my working. So what do we want? We want to find C such that the probability that x is less than or equal to C equals 0.1. which equals that command, which equals and it's kilograms, right? Space. Yeah. That all looks pretty good. Have I got anything else to do? No. That's everything for this week. See you next time.